Students, this lesson is for Friday, February 28th. We're going to be learning about factoring today, which we kind of started the process of factoring last class period, except last class period we were just doing GCF factoring, which was the reverse of the distributive property. And so today we're going to do a little bit different type of factoring. Factoring is the process of breaking a polynomial into the simplest factors possible. Usually this will be binomials, unless you're doing GCF factoring, and that in GCF factoring we ended up with a monomial and a binomial. The ultimate goal of factoring is to get rid of the exponents and leave only linear factors behind. Factoring is simply reverse distributing. And so it's like the opposite of the double rainbow, or the double rainbow that we learned last class period. So these are going to be the steps unique to the way we factor. If you were to look this up online, you would find lots of different ways of factoring. Everybody has their own way, but this is the way that we're going to do it in class. So we're going to draw an X for an X puzzle, and we'll teach you how to do the X puzzle. We put A times C at the top of the X, and we put the B term at the bottom. So A is the first number, C is the last, so we multiply those together to get the top of the X. So this will be A times C, and then we put, and then we'll put B at the bottom of it. Okay? Then we'll solve the X puzzle. You multiply to get the top, and you have to add or subtract to get the bottom. And sometimes we call it add or subtract, but it's really add. It's just sometimes when you're adding positives, that's adding, but when you're adding opposites, that ends up looking like subtraction. We're going to split the middle term using the things that we get from the X puzzle. We'll group the first two numbers and the second two numbers, and we'll factor out the GCF. So we'll go back to last class period and we'll factor out the GCF, and what's left in the parentheses should match each other. We're going to write the binomials as factors. The GCFs will make up one of the factor, and what's left in the parentheses will be the other one. And all of these rules may not have made a ton of sense to you as I was just talking about them, but as we start to work the problems, you'll get a better idea of it. Alright, so the first thing we do is we take this number and we multiply it by this one. 2 times 15 is 30, and that's the top. Okay? That is A times C. And then B just goes down here at the bottom. That's 13. Now we have to find things that multiply to be 30, but add to be 13. One of the things we can do if we're not sure about how to find these is we can go to y equals in our calculator, and we can type in 30 divided by x. Once we get it into y equals, then we can hit second graph to bring up a table, and we start looking through the values. I stopped it on a set of values here, but you could scroll up and down until you find what you're looking for. But all of these will multiply to be 30, because that's what I put in, 30 divided by x. I'm looking for the ones that'll add to be 13. So when I look here, the first set is 1 plus 30, that would be 31. That's no good. 2 plus 15 would be 17. 3 plus 10 would be 13, and that's the set that I'm looking for, 3 plus 10. They multiply to be 30, but add to be 13. Okay. Now we've split this middle term, 13x, into 3x and 10x. So when we write this out, we'll start back over at the beginning. 2x squared plus 3x plus 10x, and we'll finish with plus 15. Okay, so really all we've done is split this 13x into 3x plus 10x. Okay, then we're going to group these two, and we're going to group these two. What's the GCF of 2x squared plus 3x? Well, 2 and 3 don't have anything in common, but they do both have x's. So we'll pull out the x. Over here, what's in common between 10 and 15? 5. So we'll pull the x out to the front, X cancels into 2x squared and leaves you with just 1, so that's 2x. X goes into the 3x and leaves you with plus 3. Here, the 5 comes out, so the x goes out there, the 5 comes out here. 5 goes into 10 2 times, so that leaves 2x. 5 goes into 15 3 times, so plus 3. And what you'll notice is what's left in the parentheses is the same. So what's left in the parentheses is one of the factors, and what's on the outside of the parentheses is the other factor. This is the factored version of 2x squared plus 13x plus 15. Okay. This next slide talks about how could we check our work. Since factoring is just the reverse of distributing, we can check our answers by distributing or doing the box method that we learned in last class period. Okay, so this we could do box method, or we could do double distribute to check our answer. So let's check our answer from problem 1. We got 2x plus 3 times x plus 5 from a problem that said 2x squared plus 13x plus 15. Okay? I'm going to show you the box method here. If we do the box method with these, it would be 2x plus 3 across the top and x plus 5 down the side. X times 2x is 2x squared. X times 3x is a positive 3x. 5 times 2x is a positive 10x, and 5 times 3 is a positive 15. This is the first part of the answer, 2x squared. 10x plus 3x is the middle part of the answer. Plus 15 is the end. This shows you that it checks and works. Alright, so we start here. There's a 1 out in front of this. 1 times 3 is 3. And we're trying to get negative 4. So if I were typing into my calculator, I would type in y equals 3 divided by x. Since this is a negative number, I'm going to look for negatives in my table. Okay? And what I find is that negative 1 and a positive 4 will make a 3. So I'm splitting this, so this becomes negative 1x. Oops, I messed that up. I'm trying to multiply to get negative 3. So I picked the wrong factors here. It'll be negative 1 and negative 3. So this will be negative 3x, because again, I'm splitting this into negative 1 and negative 3, because negative 1 and negative 3 makes negative 4x. Okay, so when I go to write it, I take the first one, x squared minus 1x. I split it to this one, negative 3x, and I finish with plus 3. And I'm going to group these and group those. The GCF of x squared minus x is x, so I'm going to divide that out. Here, since the first number is negative, I have to pull out a negative. These have a 3 in common, so I'm going to pull out a negative 3. So I'll pull the x to the front. X goes into x squared and leaves us with x. X goes into 1x and leaves us with just minus 1. Negative 3 divides into negative 3 and leaves us with, first I pulled the negative 3 down here. Negative 3 goes into negative 3 and leaves us with positive 1x. Negative 3 divides into regular 3 and leaves us with negative 1, and what you'll notice is that the inside part is the same. So that's x minus 1. The rest of it is x minus 3. We could do the box method real quick to make sure that we are right. X minus 1 across the top. X minus 3 down the side. X times x is x squared. That's our first number. X times a negative 1 is negative 1x. Negative 3 times x is negative 3x. Those combine to make negative 4x. Negative 3 times negative 3 is positive 3. And that is the end part. So this does check. So this is our answer, x minus 1 times x minus 3. 3 times negative 16 is negative 48. The middle term is 2. So I'm looking for things that multiply to be negative 48 and add or subtract to be 2. So in my calculator I would type in y equals negative 48 divided by x. And so the 2 that I would find in my table on the calculator would be negative 6 and a positive 8. So I put the x's beside them because I'm splitting this. To make that, 8x minus 6x is 2x. So then I rewrite it, 3x squared minus 6x plus 8x minus 16. Group these, group those. The GCF of 3x squared minus 6x, 3 and 6 is 3. They both have an x, so it's 3x. The GCF of 8x minus 16 is 8. So I pull the 3x out front. 3 goes into 3 and leaves us with 1. X goes into x squared and leaves with x, so that's just 1x. 3 goes into negative 6 and leaves us with negative 2. X goes into x and cancels out. Bring my plus 8 here. 8 goes into 8 and leaves us with 1x. 8 goes into negative 16 and leaves us with negative 2. You'll notice that the inside part is the same again. So that's x minus 2. The outside part makes up the other side, 3x plus 8. I can box to check it. X minus 2, 3x plus 8. 3x times x is 3x squared, so that checks. 3x times that's negative 6x. 8 times x is 8x. So 8x minus 6x is 2x, that checks. 8 times a negative 2 is negative 16, that checks. So this is my right answer. Last one, 6 times negative 4 is negative 24. Trying to make a negative 5, so my calculator, y equals negative 24 divided by x. When I'm looking for my factors inside of my calculator, I find out that it's 3 and negative 8. The middle term is m, so I split that. So 6m squared plus 3m minus 8m minus 4. So these and those. These 6 and 3 have a 3 in common and an m in common. These, remember, the middle term is negative, or the first term is negative, so I got to pull out a negative. 8 and 4 have a 4 in common, and that's it. So 3 goes into 6. Well, I'll pull the 3m out front. 3 goes into 6 and leaves me with 2. M goes into m squared and leaves me with m, so 2m. 3 goes into 3 and leaves me with 1. M goes into m, so that's 2m plus 1. Pull the negative 4 here. So that one goes there, that one goes there. Negative 4 goes into negative 8 2 times. So that's 2m. Negative 4 goes into negative 4, positive 1. So you'll see those are the same. So this is 2m plus 1. And then the outside part, 3m minus 4. Okay. This time I'll check it using double distribute just to kind of show you a different method. 2m times 3m is 6m squared, which that works. 2m times negative 4 is negative 8m. 1 times 3m is 3m. And 1 times negative 4 is negative 4. So the end works. These two here combine, negative 8 plus 3 is negative 5m. So that works. So this is the right answer.